Right, welcome to lesson 2. I'm Mr. Simons. Here we're looking at limits, and there's basically limit x tends to infinity, 1 over x equal to 0. Alright, so if I give you y over 1 over x, I ask you to determine the limit. Number 1, as x and y would be inversely proportional, because as I increase this x value, my y value would decrease. So if I substitute x equal to 1, 1 divided by 1, then y is 1. If I increase x to 10, 1 divided by 10, then y becomes 0, 1. If I increase x to 100, then y equals 0, 0.01. So as y tends to 0, you see y is becoming smaller. X increases to infinity. Right? So written differently, the limit of x tends to infinity, 1 over x equals 0, because as the y tends to 0, x tends to infinity. Right, so you follow. So when I was talking about first principle, remember we're looking at how x and y interact, changes. So determine the limit, fx equals x plus 4. Right, so to determine the limit, we want the limit as x tends to 4, x plus 4. In the place of x, I substitute 4. 4 plus 4 gives me 8. So as my x value tends to 4, my y value tends to 8. So you see there, as x tends to 4, y tends to 8. So that it's limited to the value 8. Right, let's look at next one. Now we want the limit as x tends to 2, given x squared minus 4, x minus 2. Now remember, x at the bottom can't be equal to 2, because 2 minus 2 would give me 0. And anything divided by 0 become undefined. X squared minus 4, difference of 2 squares, so that becomes x minus 2 times x plus 2. No? X times x squared, negative 2 times positive 2, negative 4. X minus 2 and x minus 2 cancel, so I'm left with x plus 2. So now I substitute 2 in there. 2 plus 2 gives me 4. Right, so as x tends to 2, y tends to 4. So as I tend to 2 there, y tends to the value 4. Right? Right, so now here various problems. Number 3, we want the limit of x tends to 2 for constant 4. That would say 4 because there's no x to substitute in. Say limit x tends to 2 for 4x. In the place of 2, I place 2. 4 times 2 gives me 8. So as x tends to 2, y tends to 4. Right? Yeah, limit x tends to 2, 4 plus x, so that becomes 4 plus 2. So as x tends to 2, y tends to 6. If I limit here, take note, x cannot be equal to 0, né? Because then we divide by 0. So therefore x plus 1, that would become 4 times 2 plus 1, and 5 times 2, 8 plus 1 gives me 9, and 5 times 2 gives me 10. Right, now if I say limit x tends to infinity, I have 4x plus 1 over 5x. Right, the key concept is I need to remember x tends to infinity, 1 over x equals 0. That's the first problem I start with. So here I'm going to divide by x. So 5x divided by x gives me 5. 4x divided by x would give me 4. That simply stays 1 over x. But the limit is x tends to infinity of 1 over x equals 0. So 4 plus 0 stays 4. So my final answer, 4 over 5. So as x tends to infinity, y tends to 4 over 5. Right, so that's limiting. In short, if you enjoy and like the lesson, please like, share, subscribe. Right, but let's look at the next problem. So in problem number 8, limit x tends to infinity, 3x squared plus x minus 3 over 6x squared plus 3x minus 1. I'm always going to divide by the highest exponential value of x. So here I'm going to divide everything by x squared. So 3x squared divided by 3x squared gives me 3. X divided by x squared minus 3 divided by x squared over 6. 6x squared divided by x squared gives me 6. 3x divided by x squared gives me 3x over x squared minus 1 over x squared. So that would simplify to 3 plus x becomes 1. Take 1x away, 1 over x squared. That stays minus 3 over x squared. There, 1 minus 2 will give me x to the power 1 at the bottom. And there minus 1 over x squared. So that's 3 plus 1 over x minus. There, take note, I can write that as 1 over x times 3 over x. There's 6 plus 3 over x minus 1 over x times 1 over x to get 1 over x squared. So limit 1 over x equal to 0 if x tends to infinity. So this becomes 3 plus 0 minus, remember 0 times anything stays 0. There, 3 over x can be written as 1 over x times 3, so that becomes 0. 0 times 0 stays 0 there. So my final answer then simply becomes 3 over 6. 3 goes in itself once, goes in 6 2 times. Right, you don't get tested in the CAP syllabus on this, but I'm just explaining so that you get a better understanding of what we mean with limiting. So yes, x tends to infinity, y tends to half. Right, I wish you nothing but the best. Bye.